So again, welcome back. My name is Moritz. I'm from SIG AG. And my role within the IO-Link community is I'm responsible for the technology working group as well for quality, and also a member of the steering committee. And what I want to show you now is what did the technology group with our specification, which I think it's the heart of IO-Link, the basic system specification. And according to, is there any improvement, or we want to improve everything we do, what did we do with the IO-Link specification version 1.13 now? Okay, so why 1.13? Because we had 1.12, which was released in 2013, and this is 6 years ago. So we had 6 years of stability. And I think the 1.12 was a really good specification. We had not too much trouble in the field. Everything is working nearly perfectly. But I think there was some room for improvement. So again, why version 1.13? Well, one reason was that we had some requirements from the market, mainly about power consumption of devices. So there we had some requirements for extensions out of the market approach. The second thing is that we saw that we have gateways in the IO-Link masters. So it's not only a Profinet slave, but it's a Profinet slave with a OPC-UAI server or a web server or something like that. And we are talking about gateways. And we saw that we have to define some behavior, how gateway management can be done. So that was the second thing we thought about it. And of course, okay, we had some minor bugs or bug fixes. You know all, we have a change request database, and everybody who is developing things put in their comments, and some minor issues were that we had some small bug fixes there, and we want to do also improvement in terms of system stability. One of these system behaviors are the data storage behavior, which was defined, but at the end it was not that good in usability, I want to say. And okay, everybody who is implementing IO-Link stacks in the master side or in the device side knows that there is a package, and we had in the package a corrigendum to the version 1.12, and as well as the addendum. The corrigendum means corrections to the specification. The addendum gives an outlook what will come in the next version. And those inputs from the corrigendum and from the addendum we also put together, and at the end this leads to a new version which is now called version 1.13. Okay, so I want to talk about, let's say, 3 to 4 main topics which were improved or changed. There are some other minor topics regarding the system usability I don't mention here. So Wolfgang mentioned before that we had now 2, let's say, reset commands. You know that we had a reset to factory or factory reset, which was not very clear which data has to be reset. Now we have a factory reset for the application of technology parameters, and we had this, Wolfgang mentions, introduced the back to the box system, which means really resetting everything as it comes out, if you buy one, as it comes out from a window. So. But the main thing we did is introducing the so-called SMI. So you see here that we have the IO-Link domain as well known from version 1.12, which is here in blue. We have some ports, we have some wireless things, We have the IODD and we have the tooling, but what we saw is that now we have some of the gateway applications running on top of this or inside this IO-Link master. It could be a web server, it could be a HTTP server, it could be a OPC UA server and a field bus gateway, and all these gateway applications want to have access to the master and the master ports, and we have to do some definitions, not only defining the behavior, let's say on a port and on a wire, but in combination of that and the intermediate sections here to the gateways. And that is called standardized master interface, and the requirement was a technical one, that if we want to implement different gateway applications, we have to define the behavior to the master ports in combination of different ports, and therefore we introduced the standardized master interface. So the definitions are how to link the gateway applications to the IO-Link master. Regarding, we want to ensure functionality. So the standardized master interface defines some functionality which is mandatory to be mapped to the gateway application, maybe to map to the Profinet adaptation, maybe required or mandatory required to adapt to the Ethernet IP, or to, let's say, OPC UA, or we will see later on JSON or other servers. So we want to guarantee functionality, which is defined in the specification, to be mapped and to be seen out of the world from the gateway side. Well, what is it in details? So in details, if you look in the specification, you see a very nice picture here and a lot of terms. And what we did is that we introduced, I want to call it information model or object model. So you see here, this on the right side is the port, and there are some objects and some methods. And the objects are, one of them are the port configuration object, or the data access object, or some services, how to read or reset, something like that. So this we have introduced, and this is a master specific covering all ports of an IO-Link master. And we have also another one, which is the identification of the master itself. So we introduced an object model or information model, and some services are specified, how to deal with that. And these are regarding identification, configuration, the data storage, and very important, the device parameter access and the event handling. Not for port alone, but from the top side view. So from the IO-Link master, how to do the configurations for port 1, port 2, port 3, for all ports. And also the behavior behind, it's also specified within the SMI, which means if there is a port configuration change, what is to be done with the data storage content and so on. So that is a real new thing we put in the specification. The next topic, and this was a market requirement, and the market requirement was 200 milliamps on port class A is too less. There are applications, there are also devices in the world, they consume more than 200 milliamps, and please open up this power supply limit of 200 milliamps. And this was also described earlier in the addendum, and now we have it in the specification 1.13. And shortly spoken, there are two things. What is new? First, for port class A, now the power limit is of 200 milliamps is not there. We have it open. And usually, if you go to the MPerf connector, you can see that there is another limit coming from the connectors, which is roughly at 4 amps. So this is one thing. And the other thing we changed is for port class B. So port class B was not well defined in version 1.12, but now it is well defined. And it says, okay, two things. One, it's a 24-volt DC supply. That was not very clear in the former specification. And the other thing is that there is a constraint that it has to be isolated from power 1, which means galvanically isolated. That was also not that clear in version 1.12. And of course, we had also did some clearer definitions on the power-up behavior, the inrush current if you attach a device, and how are the slopes and the currents if you attach a device to a port. So this is more or less a clarification of that. Well, these are the two things. Nothing more had changed on the physical layout. And to be honest, this is not really the physical layer, because this is the power supply part of the IO-Link wire. Well, okay, so that was the second major point we have changed. The third one is there was also a request, mainly from the device and sensor vendors, asking for what is the pin 2? We want to have an analog output, an analog value output on pin 2, which was not covered by the specification. I know on the master side this is not an issue, but on the device side there was an issue. And now the specification, we have some additions. And if we look to here is the device side, you see now that we have different options on the pin 2. So the first option is not connected, that's a very easy one. Then it could be a digital input or a digital output. That was already mentioned in version 1.12. And we have additional option 4, which can be an analog signal on the device side. And to cover also safety, we have option 5, which can be OSSDs. So on the master side, it's slightly different. There we have not connected, I guess, yes. We have digital input, digital output, and OSSD, but not the analog value support. So this opens up that it is now, I want to say, allowed to bring on the market IO-Link devices, sensors mainly, which have an analog output on pin 2. So this is new. And please be aware, this is pin 2 for devices only, not for the master port. So this was the second extension, I want to say, we did for the specification. Well, and the third one, big one, is to improve, I call it system stability. And this is all about the block or the topic data storage. You may know that data storage, which means synchronization of the parameter set of the device with the master port, has some locking capabilities. So the device can lock something, the master can have backup and restore mode, and so on. And there are some combinations which doesn't work very well. So think about that the IO-Link master wants to write down, restore a parameter set, and the device says, no way, I'm locked. So what shall a customer do? So that was something which was not really clear in behavior. So we have simplified this behavior, or mainly spoken, we have we have the locking options within the device shall not be supported anymore. Just to make it clear that if a master, and the master is the master, wants to restore data storage content to the device has to accept it. And for compatibility reasons, well, I think the bits are there, but they shall not be used anymore. So we are compatible for that, and on the one hand, and on the other hand, we have improved the system usability for the customer at the end. As well as I think we have made some clarification about port configuration. So in general spoken, if you change the port configuration, this has also an effect on the data storage and how to deal with it, clear it or not clear it, and so on. This is also well described in version 1.13, which is making things more clearly, I want to say. Okay, so I think that was all three main topics. Other ones are really minor topics I don't want to talk about today. But what is really important, when will version 1.13 be released? And the good news is, since yesterday. So yesterday was a decision from the steering committee to release the version 1.13. It took us more than half a year to prepare it first, and then go as usual in a 3-month international review, and then working on all the change requests coming from the community outside. And now it's finalized and will be released, or is released officially. You will find it shortly, I think, on the iolink.com for download. And so we are done for the specification. But I guess a next question is also important for you, and this is the question: when to start developing devices or masters. And that is a different one. And I want to show you that we also need, or will have a timeline, and about the package. So you know that for 1.12 we have a package defined which contains the system specification, test specification, IODD specification, and manufacturer declaration. And this we also have to do here for the 1.13. So I assume that the package will be called package 2019. And also this will contain the system specification version 1.13. The green circle shows everything is done and is released. We will have an IODD specification in that specification. I marked it also green because it will be unchanged, the specification itself of the IODD. But we still have to do some work for the test specification for the 1.13. There we are working on. That's why the light is yellow and not green yet. And for the package, we also will have an updated manufacturer declaration, which is also followed by at the end of the package. And therefore means it's all about the release of the package. And the package 2019 is expected from now on by end of 2019. Then all the work will be done and the package will be ready. And when, or if we introduce a new package for development, then we have to talk, or we have to define transition periods. Everything is prepared for that, because if you look in the document product quality policy, there is in the rule how we deal with transition periods of newer packages to older packages. And you see here we have the package 2015 still valid. And after we have done that work, we will release the new package and also will say something about the transition period. Transition period means how long is it allowed to implement in master and devices version package 2015, and when will it end, and when will start the package 2019. In the product quality policy, everything is prepared for publishing. So we have here a table, and you see here it's for package 2019, it's open. And for package 2015, we had a release date, but end of validity date not. And we will decide after the package is complete. These values will fit in, and the new version of the product policy will come out. So everybody can read how long are the transition periods. But in general, as I spoke before, it's a 1.13. It's not completely something different. It's just some extension, some corrections, that's all. And that's why it's a 1.13 and not a 1.2. So don't be afraid about implementing 1.13. Well, that's the end of my presentation. So 1.13 brings some extensions and improves system stability in terms of user experience. and gives, hopefully, a more clearer picture for implementers, which means for the software developers developing the stacks. So that's all. So I want to thank you, and if you have any questions, please, you can, I think there are some minutes, have the questions right now or contact me later. Thank you.